All right, so we're trying to get ready for the linear programming test, and I want you to solve these two equations. Y equals 2x plus 7, and y equals negative 3x plus 9. There's a place that they both intersect. Now, I'd recommend, on this case, since they're both solved for y, that you graph both of them and see where they cross. Grab your graphing calculator. If you haven't got one, borrow one from me. Make it fast. Okay, on your graphing calculator then, you're going to put in those two, 2x plus 7 and negative 3x plus 9. Clear this up. X plus 7 and negative. Remember when you 2x plus 7. Enter. Then negative. This does not mean minus. Negative. A lot of people do that wrong, and then it's like, they won't graph, it won't graph. It's because you have a minus sign, not a negative. That's negative 3x plus 9. 3x plus 9. Enter. And do those actually cross each other? Oh, yes, they do. Even on my goofed up window that I have, I can still see where they cross. Now, what if I couldn't see where they cross? Then you have to zoom out enough so you can see where they cross. All right. Once you can see where they cross, you have to go second, calculate. Now, some of you are like, what are you talking about? I just hit this trace button. You won't get the exact answer. You'll get close. But you have to use the second, calculate, intersect to do this right. Yes, the trace button can kind of get you close. But first curve, it's asking me, am I on the right first line? I have a clue for you. If you have only two things graphed, you can just hit enter, enter, enter. If you have two straight lines graphed, they're only going to cross in one spot, so you don't have to guess where they cross. So you can just go enter, enter, enter. And it says it's at 0.4 and 7.8. Raise your hand if you got that. Okay, good. In a second, I'm going to make sure you're doing this legitimately, and I'm going to have you turn and show your neighbor what yours is on this next one. All right, so make sure you're doing it right. If you have questions, ask me. All right, the next one, I'm going to have it solve two ways. 2x plus 3y equals 12, and x plus y equals 6. Those are my two equations. Now, this is not as nice to graph on the calculator. Why? They're not solved. And a lot of these you might be saying, well, wait a minute, we usually graph like less than or equal to. But if I want to see where two things cross, do you get that it really won't matter that much whether I have them crossing like this and the shading is above or below? It doesn't even matter where the shading is if I want to know where they cross. All right, so it doesn't matter if these are less than or greater than or whatever for telling me where they intersect. All right, so I want you to do this with the calculator, and then I'm going to show you another way to do it. But first, let's do it with the calculator. How do you do that? You solve it for y. Then you put it in the calculator. Pause for a second to give you time to do this. All right, so the kids right now are showing the kid next to them to see if their answer for the intersection is the same as their answer. All right, then, how many of you, personally, had it correct on your calculator? All right, if you did not have it correct on your calculator, people that are not raising their hands, tell me what the problem was. I'm curious. Was it the graphing of the equation, or was it the intersecting part? You're all too chicken to say. Okay, fine. So, if I'm going to just double check and make sure where these two intersect. 2x plus 3y equals 12. I bet you some of you probably solved that incorrectly for the y. Maybe that's why you got it wrong. So if I'm going to get this one solved for y, I got to subtract 2x from both sides. So I'm going to say 3y equals negative 2x plus 12. Then I divide by 3. Y equals negative 2/3 x plus 4 divided by 3, or 12 divided by 3 is 4. That's what I really have to graph, right? You know what I'm saying? Okay. Then, that one goes in with this other one, which is a lot simpler. Y equals negative x plus 6. And just so I can get the feeling for where the mistakes were made. How many of you had the red and the green equation right? Raise your hand if you had the red and the green equations correct. Okay, that's almost everybody. Then the next part is where you put it into the calculator. And I know you guys did this right, but I'm trying to show the folks at home, so to speak, where how to do this. Now my calculator has disappeared from view because two people correct. Okay, good. So negative 2/3 x plus 4. Negative 2/3. I'm going to put in parentheses like this. 2/3 divided by 3 x plus 4. And the other one, I'm going to put in as negative x plus 6. Negative x plus 6. Enter. Graph. Can I see where they both cross with my first window attempt? No, I can't. So I have to go out of my window and make it. I could just zoom out, or I know that I need my x to be bigger. So I'm going to move down to my x max, make it like 15 or something bigger. So now I can graph it again, and I bet you I'll see where they cross. As long as I can see where they cross on the screen, I'm good, and I can. So now I'm going to go to second, and that's right above traces, calculate the intersect. This is the most powerful method for solving equations that I can tell you, because it solves any kind of equation. Graph two things, see where they cross. And then if you only have two lines, you just go enter, 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 and you should have said 6, 0. Raise your hand if you had that one right. Okay, good. Now, why would we need to know this? Because these great big problems that we do often have two equations in them, and often they have more than two equations. They'll have two equations like this that will be crossing like this, and you'll have to find the intersection point of them. And it also helps for the ACT test. Graphing two things, see where they cross, because that's the solution to. Even like, you would probably have no clue what this should look like. Sine x, where is sine x equal to 5x plus 4? I have no idea, but I could graph both sides of it and see where they cross. Okay, it's really not, it solves so many kinds of equations. Very powerful. You graph y equals sine x, you graph y equals 5x plus 4. And if they never touch each other, then that means that there's no solution. But if they ever touch each other, where they touch, if they're parallel, then they won't touch, and then that will mean that there's no solution to the expression. And that's a good answer. Okay, next thing I want to do is practice writing equations. I want you to get a blank screen up, and I want you to say x equals apples and y equals oranges on it. And then turn it so I can see it. Keep it turned. Thank you, you're good. Still waiting for some people. Don't make me wait for you, please. It can be messy, I just want to make sure you're with me. Is this working yet in the back? Okay. Excellent, thank you. Now, here's an equation I want you to write. Can you please tell me if I wanted to have 7 total pieces of fruit, how would you write the equation for that? X plus y, go on. Equals 7, yep. All right, let's say I wanted the number of pieces of fruit to be less than 10. Well, I just changed that to what? Well, less than 10. I didn't say equal. I said less than 10. All right, how about this? Write this next to apples. 75 cents. Oranges, going to be 85 cents. I think that's the numbers that I remember from Super America last time I was in there. So let's say that I go in there with 10 bucks to spend. So I have an equation for what I could buy. I want to spend, I only have 10 bucks to spend. That's all I got. You should know too that there's no tax on food in Minnesota. unless it's prepared. Like at a restaurant, there's tax. Grocery store, no tax. Yes. Are they taxing food now? Are you sure? I heard that there was a proposal, but is it actually like signed into law yet? Okay, but it looks like it's going to be. Yeah. All right, you have an answer or a question? Fire away. Perfect. Could it be equal to 10? You're right that it's not likely it would be equal to 10 unless it happens to work out perfectly, but it's possible. And if I said greater than 10, I'd be saying I want to spend more than $10. Then that's not what I said. You have $10, the most you can spend, at most. That's at most. That's correct. Okay. Next one, these are harder. That was like the G level. This is more like the X level. If you're in an accelerated class, you should be able to handle this. I want 3 times as many apples as oranges. How do you write an equation for that? And I bet you at least half of you is wrong. Really hard, really easy to mess this up. 3 times as many apples as oranges. Answer or question? Don't give the answer. 3 times as many apples as oranges. All right. Here's my advice in setting these up. If you want to have an equation implies there's going to be an equal sign. And you can't do like x plus y adding up to something. That won't make any sense. What you have to do is set x equal to y. And if I say there's 3 times as many apples as oranges, obviously it's not true that x isn't equal to y. But you have to write an equation that makes them equal each other. So you just got to figure out, where should you put the 3? All right, now here's the way I can prove it. Some people say it's 3x equals y. Some people say it's 3y, or x equals 3y. And it's not, they can't both be right. The other. Now let me prove it to you. I said there's going to be 3 times as many apples as oranges. Would you agree that at 30 and 10 would be a 3 times as many? Then if I put in 30 and 10, it should make the equation work. X is 30, y is 10. You see that the top equation does not work. And 30 and 10 here, do you see that bottom equation does work? Okay. Kind of counterintuitive. A lot of people I know will put 3x equals y. And let me explain why it works that way. If you set x equal to y, you want to take and make the smaller one. Let's say that it was really simple, that x was 10 and y was 3. If I want to make them equal to each other, I got the smaller one and I have to add something to it to make it equal to the bigger one. So here's my advice in writing these. And they give you an equation like this, where they say 3 times as big, or 2 times as big, or whatever. Set them equal. Are you with me? Good. If you set them equal to each other, then find the smaller one and build it up to make it bigger. All right, so I'm going to give you another one like this. This time I want 7 more apples than oranges. 7 more apples than oranges. First thought is find which one's smaller, x or y, and build it up. 7 more apples than oranges. Show the person what's in the pair. Either right behind you or right in front of you, one or the other. No, it's you two. It's you two. Some of you haven't turned and showed your person yet. Your person's right back there. All right. How about this? If what did I say again? What was the original statement? 7 more apples. If there's 7 more apples, you get to the situation will be like 8 and 1. 7 more apples than oranges? Okay, so if I have to make this work, I have to take the smaller one, this one, and build it up. If I add the 7 to it, now, if I add the smaller one and I add 7, now it leads to the other one. And I can check with numbers like 8 and 1, and it actually works. Okay? So it's x equals y plus 7. Yep. Let's do one more. And this one will be like the A game level. Probably only 8 of you in the room will figure it out. See if you're one of them. There's 4 more than 5 times as many apples as oranges. Say it again. There's 4 more than 5 times as many apples as oranges. 4 more than 5 times as many apples. To do this one, I would think like this. If I just did 5 times as many apples as oranges, you can tell right away which one's bigger. And it's 4 more than 5 times as many. So how do they always say to start? X equals y. Then you figure out which one's smaller and you build it up. Which one's smaller? Y is smaller, so I got to build it up. 5 times as many, 4 more than that. Raise your hand if you had that one right. Holy crap, I totally misunderstood how smart you were. Nice work. I usually am pretty good at guessing. Good for you, right? Okay, then that's cool. We're done with that part. And a typical problem today, let's do one of the homework problems together, at least start it. Would you go find Schoology? And today's date is 5-1, so we're going to be going with this. Wrong thing. This. And it says review, signed on 5-1. That one. And there's an answer key for that one too. I don't know if that other answer key ever got posted. I will get it posted, but it's not there yet. All right. Let's fight through this first problem together. We're on the practice linear programming quiz. Phil's about to take a test that contains matching questions worth 10 points each and essay questions worth 25 points each. You know, it's kind of like apples selling for 75 cents and oranges selling for 85. It's like that. He must do at least 3 matching questions, but time restricts doing more than 12. Phil must do at least 4 essays, but time restricts doing more than 15. Whole bunch of equations here. If no more than 20 questions can be answered, how many of each type should Phil do in order to maximize his score? Oh, really complicated. So how do you always start? You got to figure out what x is and what y is. What do you guys want x to be? I usually have it be the first thing. All right, so matching for x. All right. And y equals what? S. And then it says write constraints. Constraints are also equations. I'm going to give you a minute. Try to write a few. And then I'll tell you what they are. You can see if you wrote them right. Pause for a second. Here's some that I would have done. At least, okay. Matching point or matching question worth 10 points. That sounds like 10x to me. And essay questions are worth 25 points each, plus 25 for each y. All right. Now it didn't ever tell me the total number of points, did it? Okay, so then I can't really have that equal anything. Yeah. All right, next thing. Yeah, you could make up a new variable. Yeah, you could. I was looking for a number, but it doesn't seem like it has a number. All right, at least 3 matching questions. That means x has to be greater than or equal to 3. Would you agree with that one? Raise your hand if you had that one. Okay, good. And then time restricts doing more than 12. X has to be less than or equal to 12. At least 4 essays. Y has to be greater than or equal to 4. Time restricts to more than 15. Y must be less than or equal to 15. If no more than 20 can be answered, ooh, wait a minute. No more than 20 can be answered. That's total number of questions. That means that X plus Y is less than, wait a minute, no more than 20. Yeah, you're right. Less than or equal to 20, okay? Then how many of each type should Phil do in order to maximize his score? All right, notice this question doesn't ask me to answer the question. It just asked me to write constraints. There's a whole bunch of constraints. Now, there's a couple of real-world constraints. Can X ever be negative? No, so you'd say X has to be greater than 0. Well, we already have X is bigger than 3, so we don't really have to worry about that too much because it's going to be bigger than 3. And the same for the Y, can't be 0, but it's already bigger than 4, so I'm not going to worry about real-world constraints on this. The last part is write an equation for what you want to maximize or minimize. What do we want to maximize here? Maximize his score. That involves points, right? That's this little guy that didn't have a home yet. So that's the 10x plus 25y. And what do we know about the total number of points? It's going to be based on the total number of questions you got, right? So this is the thing I have to maximize. So I can put it as like P for points, or I don't know, you may look at the keywords like they think. S for score, okay, that could work. Score, or P for points, whatever, has to be equal to 10x plus 25. Are there any equations that the key picked up that I didn't? Did I miss any? Okay. All right, good. There's the beginning. And I heard the comment that this homework that we're giving you guys is like so much like the test that it's scary. So point is, if you miss the opportunity to do this homework for tonight, you'll be missing an opportunity to do well. So in other words, this is better than average practice for the quiz. This right now, this thing we're doing right now, this homework assignment is called, you did the review assignment? What about the other one called D? All right. Oh, hey, you're very well prepared then. You know, your only challenge is trying to figure out what to do tonight to get ready. So maybe, hey, interpretive dance helps some people. You could go through and check your answers on Skyward, make sure they're right. You could write an essay about why linear programming problems are so good for the practice of real-world